Hello, good morning students, and welcome back to another video for the laws of motion chapter. And today I have a numerical for you because the theoretical questions that we did in the beginning are done, and let's start with the numericals today. So the first question states that from a rifle of mass 4 kg, a bullet of mass 50 gram is fired. So we have a situation about conservation of momentum. Okay, so it is said that there is a rifle and from there a bullet is fired. Okay, the mass of the rifle is 4 kg and the mass of the bullet is just 50 grams. Okay, it is fired with the velocity of 35 meters per second. So the velocity of the bullet is given as 35 meters per second. So I am writing u. Okay, and calculate the initial velocity of the rifle. So what is the velocity of the rifle? That we have to calculate, because we know that whenever a gun is fired, the rifle or the gun or whatever you have, it gets a recoil, that is opposite direction jerk, because of the bullet fired. So the bullet moves in this way, but the gun moves in this direction. We know that. Okay, that is why they have to hold the rifle very firmly, otherwise it gets a huge jerk and it can harm the person who is firing the gun as well. So it is said that when the bullet is fired, you have to hold the rifle or the gun very firmly, because the bullet moves this way and the rifle moves in this way. Okay, this is the law of conservation of momentum. This is what you have to use. Calculate the initial recoil of the rifle. That means you have to find the velocity of the rifle, with what velocity it will move in the opposite direction, that you need to find. Okay, so if you remember the law of conservation of momentum, it looks something like this: m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. It was the law of conservation of momentum, that is that if the system remains unchanged, if the system is isolated, then the two objects in the equation, their initial momentum and their final momentum will remain the same. This is what the law of conservation of momentum said. So over here you can say that the u1 is the initial velocity of the bullet and u2 is the initial velocity of the gun. Okay, so or you can say the rifle. So and the v1 over here is the final velocity of the bullet and v2 is the final velocity of the rifle. So you know that after some time that the final velocity of the bullet will become 0 and final velocity of the rifle will also become 0, because after a jerk is applied, at that time we can control the jerk and final velocity can become the 0, and this one, the final velocity of the bullet, will also at some time becomes the 0, because we have been given the initial velocity of the bullet, that is 35 meters per second, and m1, that is the mass of the bullet, and m2, that is the mass of the rifle. We need to find this u2. Okay, so if this final velocity of the bullet is 0 and final velocity of the rifle is 0, then this 0, that means m1 into 0 plus m2 into 0 is equal to m2 u2 plus m1 u1. So 0 multiplied by any number is 0 itself, so it becomes 0 plus 0. So what you get over here is m1 u1 plus m2 u2. I hope it is clear to you students. If you have any doubts at this point, you can mention in the comment section, and this becomes 0. So what you have ultimately is mass of the bullet and mass of the velocity of the bullet plus mass of the rifle and the velocity of the rifle. Okay, now next point is simple. You need to find this u2. So what you do is you take this part of the equation and take it on the other side of the equal to sign, and what you will get is ultimately m1 u1 is equal to 0 minus m2 u2. Now obviously 0 minus any number is the number itself, but with the negative sign. So ultimately I am writing this m1 u1 is equal to minus m2 u2. Okay, because when the equal to sign changes, the side of the equation changes, then the positive sign changes into negative sign. Okay, now we simply substitute the values. because we need to find the value of u2, we have been given all the other values. All you need to do is just substitute the values. Now the important thing over here to note is that the mass of the bullet is in grams and mass of the rifle is in kilograms, and the SI unit is always kilograms, so you will need to convert these grams into kilograms. So obviously M1 50 grams, but we cannot just write 50 grams, we have to convert it into kilograms. So I am dividing it by 1000 so that we can convert it into grams, and the velocity has been given as 35, which is already in meters per second. It is not given in kilometers per hour, it is given in meters per second, minus M2 is 4 kilograms, okay, multiplied by U2. This is what we need to find. So it is quite simple. You need to find U2. You take this side, minus 4 on that side, that is equal to sign. So because it is in multiplication, when it goes on the other side, it becomes in denominator. So what it becomes, the next step like this, 50 by 1000 into 35 by 4 is equal to minus U2. Okay, if you take minus sign with you, it is alright. If you don't take minus sign, you can leave it here as minus U2. Now all you need to do is solve this. Simply solving this, what you will get, 2, and this will become 25. Multiply 25 into 35 and then divide it by 2. Ultimately what you will get as the answer is somewhat 0.44. So you will get 0.44 is equal to minus U2. Now the U2 is just the variable that we have taken. We need to find the value of U2. So we take this minus sign on the other side and it will become ultimately minus 0.44 is equal to U2. You can take, if you take minus sign on the other side, it does not make a difference. Okay, so this becomes positive and that becomes negative. So ultimately what you get is U2 is equal to minus 0.44 meters per second. Now it is quite simple over. You say that the velocity is negative. It is not negative. The minus sign over here indicates the opposite direction. Okay, always in physics this minus sign indicates the direction. That means the velocity of the bullet was taken as positive, so the velocity of the jerk or the recoil that we are getting is negative, because negative sign indicates the direction. Okay, so if this is the rifle and it is having 4 kg mass, then its velocity is minus 0.44. Now the reason is because its mass is more, that is why its velocity is less. Okay, and if the mass is less, then the velocity is more, because the momentum has to be balanced. The reason the velocity of the bullet is less, you will say that the both force and according to the third law of motion, action and reaction are equal and opposite. Let me explain. This is the particular object and this is another object which is quite smaller. Let's say they both are striking each other in the opposite direction. This one is going this way and this one is also moving in the same direction. They both have a face-to-face collision. So ultimately what happens is, this object will get a jerk and it will move in this direction, and this object will also get a jerk in this direction, because they both will collide like this and they move apart. Okay, or you can take the example of the ball as well. If this is one of the balls and this is another one, let's say they both strike each other in the opposite direction, so they both will strike and then they will move back. Now obviously the smaller ball is having a less mass and therefore this will move a longer distance, and this is having a more mass and therefore it will move less distance. The reason is that according to the law of conservation of momentum, the both of them will have their momentum balanced. So if the mass over here is less, then velocity will be more, and over here if mass is more, then velocity will be less. It's a simple equation because they both need to be equal to each other. The total momentum remains the same. So if mass is less, then velocity will be more. It's like this. If 2 into 3, and this will be 3 into 2. So if the mass is 2 kg and the velocity is 3, and then over here the velocity will be 2 and mass will be 3. Velocity will be 2 and mass will be 3. Okay, it is quite simple. Ultimately both momentum will remain the same. If the mass is 2, then velocity is 3, and if velocity is 2, then mass will be 3. Or if there is more mass, then velocity is less, and if there is less mass, then velocity will be more. So same thing is happening over here with our example as well, that over here the mass of the gun or the rifle is more, therefore its velocity is less, and the mass of the bullet is very low, just 50 grams, and therefore its velocity is more. So ultimately the momentum is balanced in both the cases. That is what we are having over here. That is m1 u1. Mass into velocity is momentum, and mass into velocity, once again, it is momentum. The minus sign only indicates that it is in the opposite direction. Okay, according to the law of conservation of momentum. Or you can also say, because the third law of motion, action and reaction are equal and opposite. Okay, so when the bullet is fired with the gun, it is getting action, but at the same time when the bullet leaves the rifle, it is also giving the reaction in the opposite direction. If you remember, when we did the derivation for law of conservation of momentum, we took something like this: F is equal to mass into acceleration, right? So we took F is equal to minus F, and then we moved further. So ultimately the law of conservation of momentum is derived from the third law of motion. So they both are related to each other. Okay, I hope it answers your question, and then we'll talk more about the numerical in the next video. Till then, have a nice day.